All right, good morning, everybody. Looks like we are live, and I'm checking my other computer to see what the delay is, just so I have a better idea. So I got this thing up here with my laptop, and I'm looking to my left at the actual stream, so I can see when my face comes up. And it's been a few seconds already. I'm just trying to identify how long the delay is, so I have an idea of how this works. There we go. All right, so looks like we are good to go. Okay. What I would like you to do while watching this is keep in mind that yesterday I messed with a couple of settings, trying to get the best possible performance out of this in terms of quality and not buffering and this and that. So if for some reason you see an issue with the quality, like if it's buffering like it did yesterday, you got to let me know in the comments, all right? What's going on, Connor? You're my solid go-to. You're the guy who keeps showing up every day. Anyway, so... today, first, I'd like to give a shout out because it's like the 90s or something. Give a shout out to my son Richie. He's turning 17 today. It's his birthday, so happy birthday. And cheers. Yeah, so he's turning 17, and today, for his birthday dinner, because of everything that's going on, it's not like we can go out anywhere. So he requested originally Chick-fil-A. He's a simple man, but we talked him out of that into something a little better, and he settled on Cracker Barrel. So we're getting Cracker Barrel to go, and that's going to be our evening. I'm not working today after school, so this is just my whole day. Now at this point, we need to focus. Thanks, Connor. We need to focus on chemistry. All right, so that was enough of a stall time and a lag time to get everybody logged in. And at the moment, we have 4 people, but only one like. So, to be honest with you, one of those 4 people is actually me on my other screen. So, there goes like number 2. All right. So, those likes and how many people watch and this and that really help what I would like to do with this channel in the future. But anyway, so here we are. Chemistry. Now, up to this point, we are still on Unit 7, okay? And we are basically at the end of the unit. We've learned, I've discussed everything that will be covered in the unit. So today what we're going to do is we're going to start by reviewing what we did yesterday and with the singles. And I will go over that worksheet that I put up on Google Classroom. I'll give you some of the answers. I don't want to do all of them because there's 20 of them, and that would take at least a half hour. Probably closer to 45 minutes or so with my explanations and questions and what have you. So I'll do a few of them. I won't do all of them. I'll probably pick a couple and just go from there. There are some weird ones in here, so I probably will discuss some of the weird ones as well. And then look to Google Classroom later today. There's going to be an assignment posted that you will be responsible for. It's not one of these suggested, just give it a shot type of things. It's going to be something that'll go in your grade book. I'll put that on Google Classroom. It'll be due Monday-ish because tomorrow's just too soon. And I still got to put the assignment together. So once my live streams are finished, that'll be my priority. Get this this assignment together for you. Put that up on Google Classroom. You give it a try over the weekend. It'll be due Monday for a grade, and we'll go from there. All right? So I hope that makes sense. And then that will be pretty much the last assignment, for the unit. We're gonna have to have some sort of big thing to cover the whole unit. So it'll be a mixed bag for the next assignment, and that'll probably be due a couple days after that. So you'll see. But after this unit, once we're finished this Unit 7, we are going. We're gonna backtrack a little bit, and we'll probably go to Unit 2. Yeah, we'll go to Unit 2, and then Unit 3 will probably be where we end the course up, to be honest with you. So it'll be 2 and 3. At least that's the order that we've done in the past, in previous semesters. So let's do it. Okay, let's see. We got 5 people, 4 likes. Connor says that, oh, hey, Tina. My beautiful wife is watching as well. Hey, Kaylin, what's up? So Connor says you got a lot of NRs or no reactions. It's entirely possible. Okay, so I'll tell you a quick story to kind of put this in perspective. When excuse me, when I was younger and I was going to start college, My parents were asking me what I wanted to major in, and I said biochemistry. Not totally understanding what I was even saying, I tried to explain it to them. And my dad was explaining how I could be the next person where I get two chemicals just to mix in a way that's never been tried before and make something extremely useful and groundbreaking and brand new. It's not exactly like that. So, Connor, this is kind of a long way of answering your question. Most reactions aren't going to happen, okay? So let's think of it this way. All the clothes you're wearing, the air you're breathing, all that stuff, is that reacting in any way with you? Maybe internally when you breathe that air in and all that stuff. But I'm holding a pen. Nothing chemical is happening here. So is the microphone and the stand and my computer, all that stuff, everything I'm touching. There's no reaction, whether it's between me and this object or the object and other objects near it. So most reactions are just hypothetical, and it's not something that will actually proceed into chemistry. So getting a lot of NRs is not uncommon. I probably should have done a better job to explain that a lot of these will be NRs, but in the end, it just saves you time. Now, we need to double check. Thanks, Connor. We just need to double check that list. Now, the list that I had is right here, and this only applies to singles. So don't do this with any other reaction type, okay? This is only for singles, and we're going to be referring to this list when we do this practice worksheet. So this worksheet is what was on the Google Classroom. We'll probably do a bunch of these. Not all of them, but a bunch of them. I know it's pretty blurry. I apologize for that. It's just my camera is what it is. So I have a light and everything on it up in that direction, but we'll, whatever. So maybe if I zoom in a little bit, that might make things a little better because we're only going to be doing one at a time anyway. That seems to look better for me. Okay, so we're going to be looking at that list. Now, what you got to realize is that anytime you see silver alone, it's automatically an NR because silver is is the last one, right? Silver's dead last. Okay? So right away, anytime you see that, just go NR. Silver, in other words, is not strong enough to replace anything on the list. He's the weakest one, no reaction. Then the next one, we do know number 2 will happen because silver over here is going to lose every fight. So we'll come back to that. Is there anything else where silver... Nope. Okay, I don't see anything else where silver is by himself at the beginning. So we do know that number 2 will happen. Okay? If we go back to that list, right here, it looks like I have zinc and silver in number 2. So zinc is definitely going to happen to replace silver, which is number 13. So 7 to 13. Now going back to this thing. Now, if that's the case, you got to realize that zinc is always a +2. I gave that clue away yesterday. Okay? And with that in mind, we got to use that as a crisscross. All right? So zinc used to be by himself. Silver used to be with nitrate. So now silver is alone. Okay? Now zinc is going to be with nitrate, and you got to do the crisscross. Okay? I got ZnNO3, 2. Last thing you got to do is balance, fix your nitrates, fix your silvers. Done. Okay? So that reaction is finished. It's that straightforward if you know what you're doing. The next one, aluminum and hydrogen. All right? So let's see if aluminum is higher ranked. Since that's by itself, we got to go back to the list. And we got, let's see, where's the list here? Here we go. So we have aluminum, which is number 6, and hydrogen, which is number 10. So this reaction can occur. All right, Connor, how you looking so far? Does that look like what you got for those first couple answers? Now, aluminum is a +3, so hydrogen will be by himself. Now, hydrogen, you see how I got a 2 here? I'm putting a 2 here because hydrogen is one of your 7 diatomics. That you have to put that 2 there. Do not think that this 2 has anything to do with this 2. It's just a coincidence. It's not something that I'm bringing it over automatically. It's only because of the situation it's in. Here I got a 2 because of the crisscross. Here I got a 2 because it's a diatomic. All right, moving on. Now I got to do the crisscross between aluminum, which is a +3, and sulfate, which is a -2. So Al2, SO4, 3. And that should be your answer there. Last thing you got to do is balance. We already discussed that hydrogens work out, but you're going to see that they get messed up and you're going to have to fix them. So I'm going to leave my aluminums to the end since it's by itself. I'll do hydrogen second to last because I just mentioned that's going to get messed up. I got to fix it. Sulfates are the next thing. So sulfate, I got 1 sulfate and 3 sulfates. Put a 3 here. In fixing my sulfates, I now gave myself more hydrogens. So I got to fix that there. And the last thing, fix your aluminums and you're done. All right, so Connor, you're saying, I see why I was wrong. I did the opposite and thought higher up was stronger, but only for a few. Okay, so like I said yesterday, think of them as like UFC rankings. So you got your number 1 contender. He's the champion. He's the best. He's going to beat everybody up. Number 13, he's the weakest. Okay, he's not going to be able to beat anybody on the list. One thing to note is that there is a 14th that I added, and 14 was for any other metal. So if you come across something that's not on the list, treat it like it's number 14, and then silver can replace those. All right, let's go back to this thing. Now, the next one, this is a weird one, okay? This is something that I did not cover yesterday, but I want to use this opportunity to explain it. I got Cl2 plus Ki. There's only one metal here, so it's not like I can switch the metals like we were. In this case, I have 2 halogens, chlorine and iodine. Now, the halogens, they can switch 2 in a single replacement reaction. Now, if they can switch, there must be some sort of order like there is for metals. Well, it turns out, if you go to the periodic table, look at the halogens. You see where you got fluorine up at the top, then chlorine, bromine, and iodine? That's the order. Fluorine is the strongest, chlorine is the second strongest, bromine is the third, and iodine is the weakest. Okay? So in this case, I have chlorine and iodine. And it looks like chlorine is ranked higher than iodine, so we should be able to switch those. So here's how you do this one. This is a variation of a single without the metals. People who aren't watching this or aren't taking the opportunity to follow along are going to miss out on this info. So Connor, Kaylin, and Tina, it looks like you guys are the only ones who are going to really get this. All right, here we go. Next, let's look at this question. We got to switch the chlorines and the iodines. That means iodine will be by himself. Iodine is a diatomic, so you got to have that too. And then you got to do the crisscross between chlorine and potassium. Potassium's first, KCl. That's a +1, -1. And then you just balance like that. So there you go. We've done 4 of them so far. Let's do a couple more. I will do number 5 and 6 without asking for anything else from you. But if there's any other question on this worksheet besides number 5 and 6 that you would like me to do, let me know in the comments in the chat on the side there. But I'm going to do 5 and 6 while I wait for that because of the delay and what have you. All right, so number 5. I got lithium and hydrogen. Well, lithium is automatically going to replace hydrogen because lithium is ranked number 1. It doesn't matter what hydrogen's ranked. So I'm going to get the crisscross between lithium and oxygen, Li2O, and then hydrogen will be by himself. You got to balance like that. You put a 2 in front of that lithium. All right, put a 2 there. Okay, that one was very easy. Why did I put that O there? Get rid of that. This should be the answer. 2 lithium, 1 water, 1 lithium oxide, and 1 hydrogen. Okay, get rid of that O. I screwed that up. Anyway, all the other previous questions, I wrote it in a different order. I always had the thing by himself and then the compound. In the end, it doesn't matter. You could do the compound and then the thing by himself. It's like saying 2 + 3 or 3 + 2. It's whatever. It's the same answer. Okay, next, let's look at copper plus iron 2 sulfate. Let's find copper and iron on that list. All right, copper is ranked number 11. Iron is ranked number 8. Copper is supposed to be stronger, but he's not. So this is a no reaction. All right, so right away, no reaction. You can move on to your next one. It's the wrong screen. This is what we want. So this is no reaction. So far I've done 6 of them with you, and 2 of them were no reaction. All right, so if there's any other questions on that worksheet you want me to do, there's 20 of them all together, and we did, let's see, 6 and 10, we did about 30% of them, give or take. Okay, so it's almost a third of the questions on those that list that I gave you. So, excuse me. So we've been at this one for about 15 minutes or so, and I'm going to kind of stall and give you a moment for an opportunity to ask some questions. And I apologize for the quality of the video. I'm looking at myself over here. For whatever reason, it's real choppy. I know the document camera is blurry. I'm trying to work that out. I don't know what the story is. I'm doing the best I can with what I got. But, okay, Connor's asking for number 16. So let's go right over to number 16. Okay, number 16. This one's not bad. You're all right. If I go to the list in a moment, I got aluminum plus hydrogen chloride or hydrochloric acid. So aluminum and hydrogen. Let's see. Aluminum is number 6. Hydrogen is number 10. So this can definitely happen. All right. It's not like this is a no reaction. So once you know that it can happen, all you do is proceed with the normal steps. Hydrogen will be by himself. That's H2. And then you do the crisscross with aluminum and chlorine. Aluminum is a +3. Aluminum and chlorine. Chlorine is a -1. So AlCl3. Crisscross. All right. Then you got to balance. This might be slightly tricky here. Okay. Save aluminum to the end. Do that one last. Now, I'm looking at the hydrogens and chlorines on the right. It doesn't necessarily match up what's on the left, right? So that's where you might have an issue. I'm going to save hydrogens to the end, right before aluminum. So I'm going to do chlorine first. Now, I have 3 chlorines here. If I put a 3 here, that doesn't help my hydrogens at all. But if I end up, I'll get stuck. Remember those steps when you get stuck, you start over, you put a 2? So I'm just going to put a 2 here right away. Now that means I have 2 aluminums. So I'll put a 2 there. All right. Now I have 6 chlorines, right? Now if you put a 6 there, you can easily fix the hydrogens with a 3. So your answer should be 2, 6, 3, 2. And you can't reduce that, so that should be the final answer. Connor, does that work for you? Let me know. Okay? Okay. I think that's pretty much it for the review, right? We did a bunch of them just now, and yeah, it is. It's pretty good. You guys are doing all right with this. Now, here's what I would like to do. I would like to discuss the quiz, a little bit more detail, or the assignment you'll get. I'm going to give you an assignment on just singles, okay, just as a review, a review of a review. And then that will be due, let's say, Monday. And then tomorrow, I'm going to put up an assignment for the entire unit, okay? So today will be just singles once again. I'm kind of thinking on my feet here. Let me think about this. How can we do this? I'm kind of stuck here because I have to give you meaningful assignments, and I want them to. I don't want to give you just busy work. So here's what I'm going to do. Okay, I'm going to put up an assignment for the entire unit today. All right? Forget everything I just said. The entire unit's assignment, so it'll be a bunch of questions on everything that we've talked about. That will be posted today. That'll be due Monday. Tomorrow, I'll do a Q&A about that assignment as a live stream. So you can start it today, ask any questions you got tomorrow, and then Monday, we will start the next video with more Q&A, last-minute questions. And then we will, in that same video, start the next unit. Does that make sense? So one assignment, new Monday, Q&A tomorrow, Q&A and new stuff on Monday. Okay? So I need some time to put that together. So that will be up later today. All right? I hope everybody's doing okay. And I'm just stuck in my office all day today, so I'm getting a little nuts. Anyway, having said that, thanks for checking in, you guys. And I hope all that makes sense. Q&A tomorrow. Okay? Let's do 8 a.m. like we've been doing the past couple days. It seems to be working. And I will talk to you then. All right. Thanks, guys. Talk to you tomorrow. Well, good morning, everybody. We are starting the honors section of the course today. And yeah, so I've been having in the past couple days a little bit of a issue with the quality, and it's been buffering and choppy and all that. And I'm trying to work that out. So let me know what you think of the quality, if it looks okay, and the audio, if it sounds all right. I know I got my test computer up here, and it seems to be okay. I mean, the picture's a little grainy. It is what it is. But anyway, having said that, at this moment we have two people watching, and one of them is me. So for the one person that's out there, say hi so I know who I'm talking to. We're going to start today by looking at the paperwork that I put up on Google Classroom yesterday. Now, there were two assignments, two things that I wanted you to try. One was a continuation of the gas portion of the mole roadmap. So I want to look at that, do a couple of those questions, and then we will do the other stuff where we did a percent composition. Percent comp is not hard, but we will extend that today to more of a word problem type of scenario and be looking at that. So let's go right to, since as far as I know there's no one here, let's go right to looking at the first worksheet from yesterday. So this is the one that we put up as a review. And originally when we did the mole roadmap, we were talking about how it's 22.4 liters for every 1 mole of a gas. And it's any gas, doesn't matter what gas it is. It's just 1 mole, 22.4. But then I gave you a formula where that can be extended and used to get you more information. So I gave you this stuff here, okay? In the box, I gave you two formulas. Density equals the molar mass divided by 22.4, or you can manipulate that to say density times 22.4 will get you molar mass. So with those two formulas in mind, which is really just one formula, you can do these questions. So it says first, calculate the density of HCl at STP. So we had the formula of density equals molar mass times 22.4. All right, so all you got to do is look up the molar mass of HCl, and you can just do that right from the periodic table. Okay, so hydrogen has a mass of 1. Chlorine has a mass of about 35. So we're going to call this 36 just to make it easier. So it's going to be 36 times 22.4, and you get your number. It's really that easy to do that first question. Same thing with number 2. You would take, since you're looking for the density, you can use the same formula. Calculate the density of H2S. Each sulfur is about 32. Yep. And each hydrogen, so you're looking at 34 times 22.4. You get your answer. All right, so that's that. Now, we get into the more difficult ones. I'm not going to do all these. I'm just going to pick and choose a couple from each part and whatever. Okay? Is there a back? No. All right, so number 3. Find the mass in grams of 1 liter of CH4 at STP. So this is just a straight conversion from the mole roadmap. So you got 1 liter, 1 sig fig. You're going to convert liters to moles, and then moles to grams. Now, again, I'm rounding. You should not be rounding, but I'm just doing this to kind of speed things up. Each carbon's about 12, and then 4 hydrogens, so you're looking at around 16. You would do the math, and you get your answer. 1 sig fig in this case because of this one there. All right, let's see. Then it says, number 4 is interesting, okay? It says the mass of 1 liter of a gas is 2.75 grams. Calculate the molecular mass. Well, you don't know what the gas is, so you can't just go to the periodic table and find the numbers to get the molecular mass. So you're going to have to start with the density. Well, you don't have the density, but you do have the mass, and you have the volume. So if you do 2.75 grams per liter 2.75 grams for every 1 liter. There's your density right there. And then you're just going to use that by dividing 22.4, and you get your molar mass. So that's an easy one, okay? It might not have looked so easy right away, but that's basically what it is. Cynthia, it's you and me and one other person. So whoever that second person is, you got to say hi so I know who I'm looking at. Yeah. Okay, so cool. Next, let's do number 5. Now, if you guys are just checking in, you can rewind a little bit and get caught up eventually. You don't have to watch this in real time, but it does help you if you want to ask questions. What I would do, if you want to go back a few minutes, you can watch it at 2 times speed or even 1.5 times speed, and that will eventually get you caught up to live. I hope that makes sense. All right, so we did 1 through 4 so far. Number 5 is an interesting one. I'll be honest with you. I found this worksheet. I glanced at it. It seemed like a good one. I'm looking at these questions in detail for the first time, so we're doing this together. Number 5, zoom out a little bit. I don't know if you guys could still see that, but whatever. All right, number 5. If you want to open up this document in another window, that might be a little better for you. Anyway, number 5 says the density of hydrogen is blah, 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 grams per liter. What will be the mass of 100 liters? Hey, this is not hard. You got a density and you have a volume. So you just solve for mass. So you start with what you got, which is 100 liters. And you're going to multiply it in a way where you cancel out liters and you go to grams. In this case, 9.00 times 10 to the negative 2 grams. So that would be the setup there. And then you could leave it there. That gets you to grams. If you wanted to continue on, you can convert it to kilograms or milligrams. Each question's a little different. Let's find a good one. Okay, let's go down to number 8. This is an interesting question. And you might see stuff like this on the quiz and stuff. All right, so the density of a gas is 1.26 grams per liter. What is the mass of 1 mole? What gas would this be? All right, well, we have the density. If you have the density, you can figure out the molar mass, which is the mass per mole, right? Grams per mole, or how many grams for every mole. That's the molar mass. So I'm going to take the density, and I'm going to cancel out liters, and I'm going to go to moles. You see why we multiply it by 22.4? Right there, that will get us grams per mole. Now, when you do this, you should, let's see. I don't have a calculator on me. Let me just do the math real quick. I don't want to give you the wrong answer because this one is more particular, and the accuracy of your answer actually gives you a better chance of getting it right. So this is going to be about 22 or 28.224, all right, according to the Google. All right, so Cynthia, I'll get to your question one second. Let me finish wrapping up number 8. Now, this is the molar mass. That's the first part of the question. The second part says, what could this gas be? Well, there's really no indication here right away unless you do a lot of these and you start to get better and better. I'm going to say that this is nitrogen gas. Now, how do I know that? Well, each nitrogen is about 14, but you have 2 of them, so that gets you to 28. That's just experience. That's just something that you would get after doing a lot of these. So I hope that makes sense for number 8. All right, Cynthia, you say, so for the first 2, to find the density, we don't divide the mass with 22.4, but we multiply. Well, let's look at this again, okay, in a different way. So you have the density, right? Calculate the density. So the density of gases is usually grams per liter, right? Well, that means if you have the molar mass, which is grams per mole, and you multiply it, oh, man, mole liter. Cynthia, I screwed that up big time. Let me look at this again. I think I got ahead of myself here. So the density equals mass divided by 22.4. Yeah, you're right. So for number 1 and 2, let's do them again because I goofed. I haven't drank all my coffee yet. Tina's kind enough to make me coffee every morning, but I rarely finish it because I'm a moron and I get caught up on myself. I was just going too fast, and I got to finish my coffee. So for number 1 and 2, you're taking the molar mass that you get from the periodic table, and then you divide it. You're going to divide it by 22.4. So same thing here. Good catch, Cynthia. Thanks for letting me know because we can go back and fix this now in real time. This would be very similar to what's happening in class because I'm a complete dope. All right, so does that answer your question? I hope that makes more sense. Just following the units, you're going to divide it out. Okay? Is that good? I'm going to move on to the next worksheet. Hopefully I don't make any other mistakes. Where did I put that worksheet? Here it is. You do not want to see my office at the moment. There's just papers everywhere. Okay. Now, this was more of a straightforward type of thing because there's just one basic formula. You got part divided by a whole. For this one, you have a sample of a compound. The whole thing weighs 14.80. Some of it is iron. Some of it is bromine. So all you got to do is a percentage for each one. Okay. Multiply each by 100. The whole thing should be in the bottom. And that's right from the question. Same thing for the part is right in the question. Do the math and you're done. Cynthia, let me know about that correction. All right. You were right. You do divide. Okay. Number 2 would be real similar. You have the whole, 9.14. You got some carbon, you got some hydrogen, you got some oxygen. You would just do 3 pieces, percent for each part, and then multiply it by 100. Same deal with number 3. So that's basically the same question, okay? Now for number 4, you have the formula. This is sodium and bromine. So all you do is, again, you got to do work for each part. Part divided by whole times 100. You would get the mass of the whole thing from the periodic table, and I'm going to round. Sodium is about 23. Bromine is about 80. I'm just rounding. So you're looking at around 103. And then you said 23 and 80. So you would do that math and you would, get your thing. Not that big of a deal. Pretty straightforward. All right, now let's move on to new stuff, okay? And again, if you guys have any questions about that, you got to ask me in the chat or send me an email or put it on the Google Classroom. And Cynthia, I'm still waiting for your follow-up if we're good or not because I screwed up. So if you guys are watching this, just know that Cynthia was right. You got to divide. Don't multiply. Okay, enough harping on that. So let's talk about the new stuff. Now, coming up, we still got a lot to cover for this unit, so we need to do a little bit today, a little bit tomorrow. But you will have an assignment on Google Classroom later. And what that will be is it'll be covering everything that we've talked about in the unit so far. Yeah. So it'll be a mixed bag of questions for everything from the unit, kind of building on the old stuff up until today, including today. And that assignment will be due Monday, okay, at noon. And we'll be doing 2 live streams tomorrow and Monday as Q&A with new stuff also on Monday. So tomorrow's a Q&A to help you with this assignment. Mondays will be starting with a Q&A to help you with that assignment, but then we're moving on to new stuff as well. So that's that. Okay, now, I'm going to show you a picture. It's kind of hard to do this, but let's get rid of this guy. Here's a picture of a question. This is technically another review, okay? This is more about the gases and stuff like that. Sorry, I got papers everywhere. I'm trying to find a blank paper. And, yep, here's one. Okay, so see this question here. This is one from the PowerPoint that you would have seen in class. And it's not a difficult question. But I need you to understand that you're going to use the info that we just did for gases to help solve this. So it says, which of the following gases would have a density of 1.25 grams per liter? Now, what I would like you to do is pause the video. I'm stalling so you can do this. Pause the video and try this on your own, and then come on back and see how I would solve it, okay? So I'm going to take a moment and write this down, that we have a density of 1.25 grams per liter, and it's going to be either SF6, chlorine, carbon dioxide, nitrogen gas, xenon, or krypton. Those are your choices, all right? So hopefully you paused it and you were giving it a shot, and we're going to go to this paper here. So this is all the info that we have. Here's how I'm going to do it. There's two ways. There's a long way and a short way. What you could do is go through each of these gases until you find one that has that density. So you would take the molar mass, plug it into one of those formulas, and use it properly to get the density, okay? Or you could start with the density and just go right to the molar mass and then find very easily, just by rounding, which one of these would have a molar mass similar to that. So if you have the density and you're looking for molar mass, you're going to do density times 22.4 liters. Okay? So I have 1.25 grams per liter times 22.4. Let's do the Google. I got exactly 28. Now, this is reminiscent of a question we just did, isn't it? We just did this one a moment ago. So there's all my work, okay? Now, if you look at the periodic table, and you can kind of quickly assess which one of these is the closest. So sulfur, I'm looking at the first one here. Sulfur is already 32 alone. Each fluorine, why'd I say it like that? Each fluorine is around 19. So 6 times 19 alone is way above 28, okay? Moving on. In other words, that one's out. Moving on. Chlorine, each one is 35. 2 of them make 70. Way more, okay? This one's got promise. Each carbon is 12, but each oxygen is 16. So you got 32 from the oxygens alone. Well, that one's out. Krypton, I'm going to go backwards now. Krypton is alone 84-ish. Xenon alone is 131. Each nitrogen, though, is 14. 2 of them makes 28. All right, I hope that makes sense. And that's how you would solve that question. All right, now, new stuff, okay? I have on my other computer the PowerPoint that you would have seen. Unfortunately, I can't show it to you at the moment because it's just not how I got to be able to do it. I'm going to go back to this thing here. Where is... Okay, so now the next part is we're going to take those conversions, or in other words, we're going to take the percent compositions that we learned how to do and use them in word problems as conversion factors. It's not difficult, okay? I'm going to give you a pretty straightforward question at first, and we'll go from there. So here's what the question might look like. Let's go down to this thing. So I'm going to write it out. It says, calculate. Man, my handwriting is getting worse. Calculate the mass of carbon. Let's move this thing. Calculate the mass of carbon in, let's do 41.0 grams of C3H8. All right, so that's the question. Okay? Now, there's a couple things that you got to realize here. First, C3H8, that's a compound. You might have to do the mass of the whole thing. The second thing you need to realize is that I'm interested in only the carbon. Okay? I'm going to give you 41.0 grams of this C3H8, Well, I want to know how many of those grams is from carbon only. So your answer can't be any higher than 41. Think about it. If I give you 41 grams of this thing, and carbon is only a portion of that, that portion can't be any higher than the grand total. I hope that's sinking in. So here's what you do. Step 1. Okay? Calculate percent carbon. That's step 1 when you're presented with a question like this. Okay? So let's do percent carbon. Let's see. We got 3 carbon. So 3 times, and I'm not going to round. I'm going to do 12.011 since I'm actually solving a question here. The whole thing should weigh about 44, but let me look it up real quick just so we're not guessing. Let's see. C3H8. I got 44.0956. Multiply that by 100. All right, now more calculations. I'm doing all this in Google. 3 times 12.011 parentheses divided by 44.0956. And I got, once you multiply it by 100, 81.716%. Now, let's see if that's all on camera here. All right. So that was the percentage, 81.716. So that means 81.716% of propane, or C3H8, is going to be from just the carbon. So now we're going to use this as a conversion factor. Okay, before we do that, because we still got to answer the question, I only know the percentage, but I don't know how many grams of carbon. So let's make a conversion factor out of this. Isn't 81.716% the same thing as saying 81.716 divided by 100? Now, mathematically that's true, okay? But we have to label this. Let's say it's 81.716 grams of carbon for every 100 grams of C3H8. Right? Doesn't this look like part divided by whole to get your percentage? Okay? So this is now a conversion factor you're going to use. It might be written like this, or it might be flipped over. It all depends on the individual question and what you're dealing with. Okay? Either one of those are valid and fair game, but you have to use them properly, and it's just converting and canceling out units. Okay, let me check something. You guys have any questions so far? Are we following along? Is this making sense? You staying with me? All right, next, let's actually address the question. Calculate the mass of carbon in 41 grams of C3H8. So that's the information we have. 41.0 grams of C3H8. Now, I want to cancel out grams of C3H8. And remember, the question's asking you, what's the mass of carbon? Well, I can cancel that out and convert it to grams of just carbon right there. And I'm going to use this conversion factor we just figured out. So that would be step 2. Use it as a conversion factor. So step 1, you got to find the percentage of the element you're interested in. Step 2 is use that as a conversion factor. You do the math. Let's do that real quick. I got 41 times 0.81716. And I got 33 with 3 sig figs, 0.5. All right, so let's make sure everybody's on camera, and that's going to be grams of just carbon. All right, not a difficult question. Just first time you're seeing it, so it might be a little goofy, okay? Let's try another one. Let's say, oh, here's a good one. All right, blank page. All right, you ready? Here we go. It says, how many milligrams How many milligrams of carbon are in 1,100 grams of CO2? All right. So what I would like you to do is pause this, give this a shot on your own. All right. And then you can get caught back up, whatever, just by speeding the video up. This is probably going to be one of the last questions we do together today. And like I said, be on the lookout for an assignment on Google Classroom that'll be due Monday. And we'll make it due at noon. Okay. All right. Here we go. So hopefully you pause and give it a shot. I'm going to show you what to do. So step one, you got to find the percentage of carbon in CO2. Let's get a mass of carbon dioxide. I'm going to a particular website that will just give me the answer. And this way, I get an exact number without me goofing it up. The whole thing should weigh 44.0095 times 100. And then use a calculator. 12.011 divided by 44.0095 times 100. And I'm going to get a percentage of 27.292. Now remember, we're doing 3 places after the decimal. So that's the sig fig rules that we're doing there. All right? So now this is my percent composition of carbon. I'm going to use that as a percentage in the conversion factor. Okay? All right, let's see here. We're up to 3 people. All right. Okay, so now we get to actually solve the question. So 1,100 grams of CO2. I want to multiply it by a conversion factor, canceling out grams of CO2. Let's make it 100. If I have 100 grams of CO2, and that is 27.292% carbon, that means I have 27.292 grams of just carbon. All right, we're not done yet because this is in grams. We want milligrams in the question. So then I just cancel out grams, go to milligrams. Now your final answer should be in 2 sig figs based on the 1,100. So let's do the math here. 1,100 times 292 times. All right. Oh, that does not look good. Okay, for some reason. Let's try that again. For some reason, I'm getting something goofy. 27.292. Yeah, okay. Sorry, I know you guys are just staring at me trying to figure this out, but it's not very different than what we've been doing in class. All right, I got in milligrams, 2 sig figs. 300,000 milligrams. Now let's analyze this answer because at first it seemed a little bizarre, right? If I were to do it in grams, that means I would just get 300 grams, right? Now that makes sense after I do that. All I did was convert my answer from milligrams back to grams. And I'm going to say 300 grams of carbon in every 1,100 grams of CO2. Now that makes sense because this is getting close to a third, right? 27% is close to 33%, almost. So that means of 1,100 grams, I should have about a third of that. Well, that divided by 3 is not that far off from here, okay? So, yeah, this number looks bizarre. At least it did to me. But if you convert it back to grams, it makes sense. So with 2 sig figs, I'm going to stick with that, all right? That seems to be legit. I think we're okay. All right, so after all that, I've been on live streaming with you guys for about a half hour now. And, man, this is getting old. All right, so, Matt, yeah, we got the same answer. I know there's a delay. You'll probably see that in a moment. Okay, so I'm going to leave it at that. There is a lot more we need to cover in this unit, so we will start that stuff on Monday. So here's what we're going to do. I'm going to post an assignment for everything that we've covered so far. That'll be due Monday. I'm going to do a Q&A tomorrow about that assignment. That assignment will be due Monday at noon, so we'll do a Q&A and new stuff on Monday. Okay? Okay, so that's that. You guys have any particular or specific questions, send me an email, put them on Google Classrooms, whatever you got to do. Yeah, I'll do my best. Okay, I hope that makes sense, and keep an eye out for that assignment shortly. Everybody good? All right, I'll talk to you again tomorrow at 9 a.m. See you then.